to this class. For today, we'll be trying to explain a course called Theory of Structure. So, right, let's consider this study of this course. So, let's start with the concept of theory of structure. Before we dive into theory of structure, let's first understand the meaning of structure. So, by definition, what is structure? So a structure is simply the assembly of members such as bar, building, and cables, etc. Alternatively, I can define structure as anything that can be constructed or built from different integrated parts on the surface, on the ground, or perhaps on the location on the ground. That's the definition. Alright, I will understand the definition of structure and the alternative way of defining structure. Let's discuss one important concept based on structure, purpose of a structure. Let's consider the purpose of a structure. What is the main purpose of a structure? It's very important to know the main purpose of structure. The main purpose of the structure is to transmit the external load from the building directly to the foundation. That's all. You can go online. There are series and other purpose of structure, right? But the main one is just for the to transmit the external load from the building directly to the foundation. That's all. Alright, having understand the concept of purpose of structure and the definition of structure, let's look at one important concept called type of structure. Right? Types of structure. Types of structure. Let's discuss the type of structure that we have. So when it comes to structure, there are two distinct ways of classifying structure. Number one, we have the statically determinate structure and we have statically indeterminate structure. So the first one there is called statically determinate structure, and number two there is called statically indeterminate structure. So these are like the two main types of structure that we have. Number one is called the statically determinate structure, and number two there is called statically indeterminate structure. Let's try to understand. Let's try to take them one after the other and explain what they mean. For the first one here, let's discuss statically determinate structure. What are statically determinate structure? Statically determinate structure are those structures whose reaction can be determined using the equation of static equilibrium, right? So when it comes to statically determinate beam structure, perhaps not beam structure, when it comes to statically determinate structure, their reaction can be determined using the equation of static equilibrium, as we know, right? The equation of static equilibrium are the summation of h to be 0, summation of v to be 0, and moment at summation of m at any point is 0. These are like the three conditions of equilibrium. So for the first structure, I mean the statically determinate structure, it actually can let's say it accept the condition of equilibrium. Let me put it that way, right? So I said it's simply or perhaps statically determinate beam are those beams whose reaction can be determined using the equation of static equilibrium on the board there. Alright, let's discuss okay, if I move on to the second one, note something here. The beam that actually work for this kind of structure are Number one there, we have simply supported beam, right? Number two, cantilever beam, and three, overhanging beam. So these are like the three types of beam that actually work for this kind of structure. So simple supported beam, cantilever beam, and overhanging beam. Why? Because these three beams here can only work for what? Equation of static equilibrium for these three here. So if I want to calculate the reaction for this kind of beam, I can only use the equation of equilibrium. That's the idea there. Okay, let's discuss the second one called statically independent beam. Alright, for statically dominant beam, here is what you need to note. Statical dominant structure, perhaps not beam, please, structure. So statical dominant structure are those structure whose reaction cannot be determined using the equation of static equilibrium. That's all, right? It's like the opposite of this one here, right? So the beams that actually work for this are fixed beam, and number two they have continuous beam. These are like two types of beam that actually suit or perhaps agree with statically independent structure, right? So I haven't discussed about the definition of structure, the purpose of the structure, and the two types of structure that we have. Let's discuss one more important concept, right? Before we dive into derivation, right? Called let's discuss something called deflection. Let's discuss deflection, right? So what's the definition of deflection? Deflection is simply the deformation of a member, that's all, right? So when you apply a load to a structure, or perhaps to a structure, such that the structure no longer withstand the load. Hence, this man will occur. Deflection occurs in that case, right? That's like the idea behind that concept there. Alright, deflection is represented by Y, right? Y is used to represent deflection, right? So when it comes to theory of structure, note two things, please. We are going to be deriving the slope equation and deflection equation of all this beam here, you see here, right? So when it comes to when it comes to the structure, note two things. We'll be deriving for slope equation and also slope equation is C, represented by C, while deflection equation is Y. So when it comes to the structure, we'll be actually looking for slope equation and deflection equation of some structures of perhaps let's call it beam in this case, right? Of some beams, right? So I want to know something, that there are actually three distinct ways or perhaps method of solving or perhaps deriving the slope equation and deflection equation. Three methods, but I will introduce to you just two, right? So the method, put on one line space paragraph, method of deriving the slope equation and deflection equation of a structure. Number one, it is actually three. I'll show you two, right? So the method includes, number one, we have the double integration method, and number two there is called area distinct method of determining the slope equation and deflection equation of several beam, right? Either simple beam or perhaps overhanging beam, continuous beam, right? With each with different type of load, either uniform splitted load or point load or uniform varying load, right? So that a method for that guy there. All right. So this is like the introduction to theory of structure, and our next class here will just be on derivation. So first class, you try to derive the slope equation and deflection equation of a simply supported beam with uniform splitted load. You that one, you find for the slope equation and deflection equation. So I'll drop the link for those classes in the description of this video, right? So I'll arrange them one after the other, or perhaps you can check our playlist on theory of structure, right? It is well arranged. What you need to watch first before the other one, right? That's like the concept behind this man here. So see you in the next class.